Hello children, welcome to my online classes. Today's topic is triangles, chapter number 9 of class 9. From lower class already you know about triangles. So I am just going to revise all the concepts that you have studied till now about triangles. Okay. First is if you take 3 points, suppose A, B and C, not in a straight line. If you take 3 points A, B, C not in a straight line and you join them, okay, the figure, the two-dimensional or the plane figure that you get is called a triangle. So this is a triangle ABC. Okay, we name it like this: A, B, C. It can be named as BC also. Okay, just you have to name the 3 vertices: ABC, ACB, BCA, BAC, etc. So you have 3 vertices ABC. Okay, 3 sides AB, BC and AC. Vertices 3 A, B, C. Since we have 3 vertices, therefore we will have 3 angles: angle A, angle B and angle C. Sides also 3: AB, BC and AC. Okay. Next, properties. The first property is called angle sum property. Okay, the first property is called angle sum property. That means if you add angle A, B and C, you will get 180 degree. Okay, so angle A plus angle B plus angle C is always 180 degree. Okay, remember the sum of angles of a triangle is always 180 degree. Number 2 property we have exterior angle property. Okay, the second property is exterior angle property. Now what is this extra angle property? We will get extra angle if we produce any side of this triangle. Suppose I produced in side BC 2 point, suppose Q. Okay, I produced side BC to point Q. Now this angle which I get outside the triangle is called exterior angle. Okay, and according to extra angle property, this angle will be equal to sum of the interior opposite angles. Means this angle is equal to angle A plus angle B. Okay. Means angle ACQ is equal to angle A plus angle B. This is called exterior angle property. Okay, so we get an exterior angle is equal to sum of its interior opposite angle. Remember this property, you already know this property. An exterior angle is equal to sum of its interior opposite angle. Okay. Similarly, suppose I will produce AB. Okay. Suppose I will produce AB. This is B. Suppose this point is P. Okay. Then this angle will be equal to this angle plus this angle. That means angle PBC, this angle is equal to sum of its interior opposite angle, is equal to angle A plus angle C. Angle C means this angle, not this angle. Okay, this angle. Better like angle ACB. Okay. To be specific, if a vertex contains more than one angle, then to be specific, we use three vertices to represent the angle. Okay. So angle A plus this angle means angle ACB. This is called external angle property. So these are the two properties which you have to remember. Already you know from lower class. First one is angle sum property. Means sum of the angles of a triangle is always 180 degree. Second one is external angle property. Means one external angle is equal to sum of its interior opposite angles. Okay. Now let us move to types of triangles. Now let us move to types of triangles. Okay. There are two ways to classify. The first method is based on angles. Okay. The second method is based on sides. Okay. There are two ways to classify triangles. First one is based on angles. The second one is based on sides. Let us move to the first one, based on angles. Okay. Based on angle, there are three types of triangles. First one is acute angle triangle. Means each angle of the triangle will be less than 90 degree. Acute means less than 90. Okay. So acute angle triangle means each angle of the triangle will be less than 90 degree. Second one is obtuse angle triangle. Okay. Means one angle of the triangle will be more than 90 degree. One angle. At a time, two angles cannot be more than 90 degree. Okay. Because if two angles will be more than 90 degree, then it will not be a triangle. Okay. Already the sum of the two angles will be more than 180, so how it will be a triangle? So remember, there can be at most one obtuse angle in a triangle. There cannot be more than one obtuse angle. Okay. So if one angle of a triangle is more than 90, then we say that it is an obtuse angle triangle. Okay. Next, or the last one, it is special triangle. Okay. Right angle triangle. Okay. Means one angle of the triangle will be 90 degree. Okay. I am drawing pictures for this. I am drawing a rough picture for each time for the acute triangle. Suppose randomly I am choosing values. Okay. Suppose angle A is 80 degree, angle B is 70 degree. Okay. So angle C is 30 degree. Okay. Such a triangle is called acute angle triangle. You can see each of the angles, angle A, angle B, angle C, 80, 70, 30. Each angle is less than 90 degree, so it is an acute angle triangle. Next is obtuse angle triangle. angle is 30 degree, this angle is 20 degree, and this angle is 130 degree. One angle is more than 90, so this is an example of obtuse angle triangle. Okay. Next is right triangle. We have a special chapter on right triangle in class 9 that we will study later on. Okay. Now just introduction. Okay. Right triangle. One angle will be 90. Remaining two angles we don't care. Okay. Suppose this is P, Q, R. This angle should be 90. One angle should be 90. Suppose this angle is 55 degree. This angle is 35 degree. Okay. So such an example is called right triangle. Okay. See, one angle is 90 degree. Okay. These are the three types of triangles based on angles. Okay. Next we will move to classification of triangles based on sides. Okay. Based on sides. Ready? Based on sides, there are two types of triangles. One is scalene triangle. Scalene triangle means all the sides are different. Okay? All the sides are different. I am drawing a picture for this. It may be acute triangle, it may be right triangle, it may be obtuse angle triangle. That is not important here. Okay? But the condition is all the sides should be different. Suppose this is 4 cm, this is 6 cm, and this is suppose 8 cm. You can see all the sides are different. 4, 6, 8. So this is an example of scalene triangle. Okay. Next is isosceles triangle. Next is isosceles triangle. Many students commit mistake in isosceles triangle. They think that isosceles triangle is a triangle in which two sides are equal. No, that is not the correct definition of isosceles triangle. Isosceles triangle is a triangle in which at least two sides. Remember this part. At least two. Okay. At least two sides are equal. That means two sides can be equal, three sides can also be equal. If two sides are equal, then it is an isosceles triangle. If three sides are equal, then also it is an isosceles triangle. But we give a different name, a special name to the isosceles triangle having three sides equal. So remember, an isosceles triangle is a triangle in which at least two sides. Don't forget this one. Okay? At least two sides are equal. Okay? So I am drawing a rough picture for this isosceles triangle. A, B, C. So this is equal to this, and this is different. Okay? So this is an isosceles triangle. One more. P, Q, R. All three are equal. Then also it is isosceles triangle. Okay? But this becomes a special triangle. Okay? This becomes a special isosceles triangle. So we give a different name to it. We say it is equilateral or equiangular triangle. Okay. So if two sides equal, isosceles. If three sides equal, then also it is isosceles, but we give a different name, equilateral triangle or equiangular triangle. So remember this, equilateral triangle is not different from isosceles triangle. Okay. it is special case of isosceles triangle, that you have to remember. So remember, based on size, usually teachers and students think that there are 3 types of triangle. No, there are only 2 types. One is scalene triangle, the other is isosceles triangle. And this isosceles triangle will become equilateral triangle if all the 3 sides are equal. Okay? So these are the different types of triangle. Now let us move to some terms related to triangle which are very important. You have to remember everything that I explained. All the terms you have to remember also. First one is median. First one is median. Now what is a median? Okay, I am giving its definition. It is a line segment. Okay, it is a line segment that joins vertex of a triangle and the midpoint of its opposite side. Remember this, it is a line segment that joins the vertex of a triangle. Okay, vertex of a triangle and the midpoint of the opposite side. Okay, let us see. Suppose we have a triangle A, B, C. Okay, let the midpoint of AB be P. Means this is equal to this. Okay, P is the midpoint of AB. Its opposite vertex is C. If we join P and C, then we will get one median. Let us join. So this CP, this new line segment CP, is the median of this triangle corresponding to the side AB. Okay, we can have one more median. Let the midpoint of BC be Q. Okay, Q is the midpoint of BC. I have taken scalene triangle. Okay, you don't need to take special triangles like equilateral triangle or isosceles triangle. It is applicable everywhere for scalene triangle, for equilateral triangle, for isosceles triangle, acute angle triangle, right triangle, all types of triangles. Okay, so let us take the midpoint of BC Q. Now the opposite vertex is A. Let us join them. So this AQ is another median of this triangle ABC corresponding to the side BC. Okay, again let us take the midpoint of AC. Let it be R. Okay, so AR is equal to CR, midpoint. Okay, now let us join this midpoint of AC to its opposite vertex B. Okay, now this is another median. Okay, so CP is one median, AQ is another median, BR is another median. So there can be 3 medians of a triangle because a triangle has 3 vertices and 3 sides. Okay, so how many medians? There will be 3 medians. Okay, then these 3 medians will always pass through the same point. See, the point of intersection is one only. All the 3 medians are passing through the same single point. Okay, so we say that the medians are concurrent. Medians are concurrent. Concurrent means if 2 or more lines or more lines pass through the same point, we say that the lines are concurrent. See, AQ is a median, it is a line, BR is another median, another line, CP is another median, another line. These two lines are passing through the same point, so we say that they are concurrent. Okay, so this is the meaning of the word, the mathematical word concurrent. Okay, next we have given a special name to this point. Okay, there is a special name of this point of intersection of the medians. It is G. Okay, remember this, G, and G stands for centroid. Remember this, G stands for centroid. Okay, actually it is the center of gravity of this triangle. Okay, center of gravity of the triangle. That means if you take a wooden piece, okay, wooden plywood suppose, and you make a triangle from it, cut the plywood and make a triangle from it, locate the centroid by drawing the medians. If you put your finger, if you put the tip of your finger at G like this, you can balance the triangle. That means this G, which is called centroid, is the center of gravity of this triangle. And one more important property we have. Remember, the centroid divides each median in the ratio 2:1. Okay, that means AG by GQ is equal to BG by GR is equal to CG by GP is equal to 2/1. Remember this relation. AG by GQ is equal to BG by GR is equal to CG by GP is equal to 2/1. Okay, so centroid divides its median in the ratio 2:1. Its proof I will give in class 10, not now. Okay, just you have to remember the ratio. Okay, 2:1. That means if this is 6 cm, if AG is 6 cm, GQ will be 3 cm. How? Okay. Similarly, if BG is 8 cm, GR will be 4 cm. If GP is 5 cm, okay, GP is 5 cm, CG will be double. Okay, CG will be 10 cm. Okay, so this is the relation that you have to remember about median. Okay, so median is over. Medians are the line segment that joins a vertex of a triangle to the midpoint of the opposite side. They are concurrent. Okay, there are 3 medians. The point of intersection is called centroid. It divides each median in the ratio 2:1. Okay. The next concept is altitude. Okay. It is also known as height, altitude or height. Now let us see what is altitude. Okay. Let us draw a triangle. I am drawing acute angle triangle. Okay. It is for right triangle also. It is for obtuse angle triangle also. Suppose this is A, B, C. Suppose I will start from one vertex. Suppose A. From A, I will draw one perpendicular on BC. Okay. From A, I will draw one perpendicular on BC. Suppose this is P. P is not necessarily the midpoint of BC. P may be the midpoint of BC, may not be the midpoint of BC. That we cannot say. Okay. So many students get confused here. They think that if P is perpendicular means P is the midpoint of BC. Wrong. No. P may be midpoint, may not be midpoint. That you cannot say. Okay, simply it is perpendicular. So this AP is the altitude of this triangle ABC corresponding to the side BC. Okay. So let us go for the definition from this diagram. Okay. It is a perpendicular drawn from any vertex of a triangle. Okay. So it is a perpendicular drawn from any vertex of a triangle on the opposite side. Okay, see, AP is perpendicular corresponding to side BC. Similarly, from B we can draw perpendicular on AC. Let us draw. Suppose this is Q. Okay, so now BQ is perpendicular to AC. So BQ is another altitude. Okay, corresponding to the side AC. Again, from C we can draw one more altitude on AB. Let us draw. Okay, this is perpendicular. Suppose this is CR. CR is perpendicular to AB. So how many altitudes we got? AP, BQ and CR. Altitudes are 3. Okay, we have 3 altitudes. Okay, again you can see all the 3 altitudes are passing through the same point. See, one point, that means they are also concurrent. Okay, altitudes are concurrent. That means they pass through the same point. Okay, and we give a special name to this point O. Okay, O. O means here orthocentre. Remember this, the point of intersection of altitudes of a triangle is called orthocentre, named using the capital letter O. Okay, and altitudes are concurrent. Okay, you can see this is an acute angle triangle. All the altitudes are inside the triangle, but altitudes can be outside the triangle also. For example, now I will take an obtuse angle triangle. Okay, now I am taking an obtuse angle triangle. A, B, C. By definition, altitude means a line segment that is drawn from one vertex perpendicular to the opposite side. Okay, now see, suppose I want to draw a perpendicular from A on BC, it is not possible. If you draw any line from A on BC, they will not be perpendicular. So in this case, what we have to do? We have to produce CB like this. Okay, the line and the side CB is produced like this. Then we can draw perpendicular. Then from A we have to draw one perpendicular, suppose AP. So AP is the altitude of the triangle ABC corresponding to the side BC. But you can see the altitude is outside. Okay, you can see altitude is outside. So remember, altitude can be inside, can be outside. Now let us draw altitude from B. The opposite side is AC. This will be inside. Okay, this will be inside. Suppose this is Q. BQ is the altitude of the triangle ABC corresponding to the side AC. It is inside. Now let us draw altitude from the vertex C on the side AB. Okay, the opposite side is AB. Okay, but you can see from C, if you draw any line on AB, it will not be perpendicular. So again we have to produce. So produce AB, produce AB, then we can draw perpendicular. This is perpendicular R. So CR is another altitude. Okay. So this is H1, this is H2, this is H3. So you can see out of the three altitudes, one altitude is inside, the other two altitudes are outside. Okay. Now you may wonder here, I told that just a few seconds before that altitudes are concurrent. They pass through the same point, which is called orthocentre. But in this case, the three altitudes H1, H2, H3 are not touching each other. Okay. So are they concurrent or are they not concurrent? Let us see. Again, they will be concurrent. If you produce these altitudes like this, my diagram is not accurate, so I may not get. Okay. If you draw properly, then you can get. You know how to draw altitude using compass. Now produce the second altitude like this. Ready? Produce the third altitude. Okay. So if you produce the three altitudes, my one is not accurate. Okay, I have drawn roughly. If you draw accurately, three altitudes will always be concurrent. This point will be called orthocentre. Okay, this is for obtuse triangle. Now let us move to right triangle. A, B, C. Okay, in acute triangle, altitudes are inside. In obtuse triangle, one altitude is inside, two altitudes are outside. Okay, ready? Now let us move to right triangle. Let us see where are the altitudes. Now let us try to draw altitude from A on BC. Okay, altitude means from A we have to draw a perpendicular on BC. But you can see the diagram. There is already one perpendicular. AB is perpendicular to BC. That means this side AB. Here AB is the side, but it is also the altitude corresponding to the side BC. Remember this. Okay. In one point of view, means from one point of view, AB is the side of the triangle. From another point of view, AB is the altitude of the triangle corresponding to the side BC, because AB is perpendicular to BC, you can see. Similarly, now let us try to draw altitude from B on AC, the opposite side. Okay, here we can draw. Suppose this is P. So BP is another altitude, H2. Okay, this is inside the triangle. Okay. Now let us move to the third altitude. Third altitude means from C we have to draw one perpendicular on AB. But you can see there is already one perpendicular from C on AB. CB perpendicular to AB. That means this is the third altitude. From one point of view, BC is a side of the triangle. From another point of view, this BC is the altitude corresponding to the side AB. Okay, so remember this concept about altitudes. In case of acute triangle, all the three altitudes are inside the triangle, and the point of intersection, that is orthocentre, is inside. Okay, if you go to obtuse angle triangle, see this one altitude is inside, two altitudes are outside, and the orthocentre is outside. Okay, but always they are concurrent. If you move to right triangle, one altitude is inside, the remaining two altitudes are actually the sides containing the right angle. See, AB and BC, these are the sides containing the right angle, also they are the two other altitudes. Okay, so remaining two altitudes are the sides of the triangle, and again they are concurrent. See, one height, second height, third height. They are intersecting at one point. The vertex containing the right angle. So again they are congruent. So this is about altitude. Okay. Now let us move to the third part, which is angle bisector. From the name we can understand that the angle will be bisected. Okay, you can take any type of triangle. Suppose I am taking one acute triangle A, B, C. Angle bisector means just you have to bisect the angle. Okay, suppose I am bisecting angle A. Okay, AP bisects angle A, but do not think that AP is perpendicular to BC. This AP may be perpendicular to BC, may not be perpendicular to BC. Again, this AP may bisect BC, may not bisect BC. That means P may be the midpoint of BC, may not be the midpoint of BC. So don't try to relate. Okay, median is different, altitude is different, angle bisector is different. The fourth one will also be different. Don't try to relate. Here the angle is being bisected. That doesn't mean that this AP will bisect BC. So don't think that AP is altitude, or don't think that AP is median. No, maybe median, may not be median. We cannot see. Okay. Now angle bisect. Angle B will be bisected. Okay. So let us bisect. Angle B has been bisected. Suppose this is Q. Angle B has been bisected. Ready? Third angle C will be bisected. Let us bisect. Okay. Now angle C has been bisected. Suppose this is R. So you can see there can be three bisectors: AP, BQ, and CR. Okay. P angle bisectors, because there are three angles. Okay. Again, you can see all the three bisectors are passing through the same point. Means again they are concurrent. Okay. Okay. That means angle bisectors are also concurrent. Now this point of intersection is given a special name I. Okay, and I stands for Incentre. Incentre. Remember this. I stands for Incentre. Remember this. The point of intersection of angle bisectors is called Incentre. Ready? Now the fourth part and the last part of this video. Fourth one is perpendicular bisector. Okay, fourth one is perpendicular bisector. Let us take a triangle ABC. So we will perpendicularly bisect the sides. Let us target AB. Let the midpoint of AB be, suppose, P. Okay, this is equal to this. Perpendicular also, bisector also. Okay, that means we have to draw a line which will be perpendicular to AB. Also, it will be bisecting AB. Okay. Okay. L1, line L1. is the perpendicular bisector of side AB. Okay, see this line L1 is not passing through C. It may pass through C, it may not pass through C, we cannot see. Okay, and this is not altitude. I told you don't relate the concepts. Okay, altitude is different, median is different, angle bisector is different, all are different. Okay, this is simply a perpendicular bisector. Now we will draw the perpendicular bisector of BC. Suppose the midpoint of BC is Q, BQ into CQ. Okay, midpoint of BC is Q means BQ into CQ. We will draw perpendicular through Q. Suppose this is line L2 perpendicular to BC. Okay, this is the perpendicular bisector of BC. Now we will draw the perpendicular bisector of AC. Let the midpoint of AC be suppose R. Okay, R is the midpoint of AC. So AR is equal to CR. Then we will draw a perpendicular through R. Okay, so L1 is the perpendicular bisector of AB, L2 is the perpendicular bisector of BC, L3 is the perpendicular bisector of AC. You can see again they are passing through the same point. That means perpendicular bisectors are also concurrent. Okay, perpendicular bisectors are concurrent. Remember this. Okay, perpendicular bisectors are also concurrent. That means they pass through the same point. Okay, you can see one point. This point we can give any name to this. Usually we name O. Okay, but you can give any name. We say that it is circumcentre. Remember this. The point of intersection of perpendicular bisectors of a triangle is called circumcentre. Okay. So these are the four different terms related to triangles. First one is median. Median means it is a line segment that joins the vertex of a triangle and the midpoint of the opposite side. There will be three medians. Okay, and the point of intersection is called centroid. Means medians are concurrent. Okay, that point centroid divides each median in the ratio 2:1. Then the second concept is about altitude. Altitude means a perpendicular drawn from one vertex of a triangle to the opposite side. Okay, and all the three altitudes are concurrent. That means they pass through the same point, and the point of intersection is called orthocentre. Okay. Third concept is angle bisector. You know what is angle bisector? They are also concurrent. Okay, and the point of intersection is called incentre. What is the relevance of incentre? That I will explain later on. Okay, not now. Incentre has a lot of relevance. Fourth concept is perpendicular bisector. Okay, means you have to perpendicularly bisect the sides of a triangle. Again, they are concurrent. They will pass to the same point, which is called circumcentre. Okay, so this is the end of triangles part 1. Thank you for watching.